Hello guys, my name is Somteniso and I'm also known as Coach Boo. Welcome into the Mathsbuddies channel. In this channel, I'll be sharing with you guys lessons on methods you can use to solve any maths topic that you might or might not be struggling with as a grade 11 or grade 12 learner. So if you are new to the channel, I would like to welcome you and I'd like to please subscribe so that you won't miss when another video gets uploaded. So without further ado, we're going to jump straight into this week's session. This week we'll be discussing exponents. I'll be showing you guys some of the methods that you can use to solve exponents and equations, rational exponents and equations, and also help you to identify the difference between the methods of solving exponents and rational exponents. But before I go there, I wanted to show you first some of the laws that we might need as we're going to do the exercises. Here we remember the laws that we discussed in grade 10 here, and also remember some of the axioms. And lastly, we also talked about the negative exponents. And then in the negative exponents, I know that it's quite confusing, but to explain this one, I can start off on the axiom and say here, as you see in this third axiom here, we have a to the power of negative n. So the minute you have an exponent that is a negative power, this negative exponent has a denominator which is 1. And then once you show the denominator, what happens now is that the power, the exponent, since it's negative, what it happens is it is the 1 that will go below because it was on the numerator, and then here it's on the denominator, there's 1 there, so it's going to come to the denominator, leaving 1 at the top. Now don't make the mistake and say this a to the power of negative n, it goes to the downside while this 1 is going to the upside. No, that's not how it works. It works only one way. The power with the negative, well, the exponent with the negative is the one that goes to the downside, or it was at the bottom, it was going to be going to the upside. All right, okay, so this is also an explanation to that. As you can see, the first point here, it is only a to the power of negative n that went to the downside, but b remained on the downside of the fraction. Same applies here. B was on the downside of the fraction, and then it went upside. So you know the upside and downside. Upside is the numerator and downside is the denominator, just to make things clear. Now, one of the things that I might think that you guys might have not discussed in classes is prime factorization, right? Now, in exponents, we always need to make sure how to do a prime factorization. Now, if you don't know what is a prime factorization is taking a big number and writing it into small numbers, right? Using its prime numbers. So you're writing it as a product of prime numbers, basically. And to do that, we can also do it on our calculator. So what you can do on your calculator is, let's say you want to find prime factorization for 75. So you're going to type in 75, then you're going to press equal sign, then after that you're going to press shift here, and then you see that there's a button says fact, right? And you're going to press on that button. As you can see, it gives you this number but in a prime product, right? And then this is very useful on exponents because it helps us to understand how to basically apply the laws with other numbers that we're going to be encountering with, right? All right, so now one of the things also that you might have discussed now as a grade 11 were rational exponents. Now the rational exponents, we know that if we have a power which is an exponent which is a with the power of a fraction m over n, then that becomes what? An nth root of a to the power of m. Right, now one of the things that I need to clarify also is that m and n are numbers, right? In the exponents, one of the things that I might say right now that you might always encounter as you be writing exponents is that when you're getting questioned on exponents, when they're talking about exponents, you will always notice that the exponents, they will have a power of a variable. For example, they will have like 2 to the power of x, right? Or they will have 27 to the power of x plus 1. Those are always considered, right, on tests as exponents, right? And then there's also the one with the rational exponents. Now with the rational exponents, the power is no longer a variable. The power is no longer a variable. Now the base is the variable, right? But the power, it is a number, right? A number. So it can be a number like that, right? So this is always considered as a rational exponent. So now that we got everything out of the way, I think it is best that we go on to the exercises so I can show you guys some of the methods that you can use on solving each and every exponent. So we're going to start off with the exponential expressions. here in the exponential expressions, you can see that we give a 2 to the power of 2n minus 2, all of that as an expression, right? I'm not going to read all of it. As you can see, guys, it is already there. So now one of the things that you always need to do when you're discussing with an exponential expression is to always first prime factorize, right? It is always to prime factorize. Now remember, I showed you how to prime factorize in the calculator, but when you do that, we're going to get this part as like that, because 2 is already prime factorized, but 25 is not. So which means 25, we're going to change that into 5 squared, right? And then 10 is also not a prime number, so we need to prime factorize that. So it's going to be 2 times 5 n minus 2 all divided by 8 is a prime number, so it's going to be 2 to the power 3 n minus 1, and then 5 is a prime number, so we're just going to leave it like that. Now this is very important, because you see now once you have prime factorized, you notice that all the expressions that are here, or all the products that are here, right, they have a base of 5 and a base of 2, so which means you can be able to now apply the laws of exponents, right? But now let's simplify this. You're gonna have this one, and now here we can see this is a square root, so if it's a square root, then we can say 5 squared, right, to the power of n over 2, right? And then this one we can apply the law of exponent, which is 2 to the power of n minus 2, 5 to the power of n minus 2 over, and then this one is going to be 2 to the power of 3n minus 3, then that one is going to be like that, right? Then now you can see this 5 to the squared is going to cancel out, right? Let's see, they cancel that, so you're going to leave with n. And then now I just want to write this in a simplified way, so once we cancel the 2's, it's just going to be 5 to the power n, right? Then from there we're just going to apply the laws. So applying the laws, we can start at the top just not to confuse people. So we're going to start off with the 2, because we can see 2 2. So now applying the law there, we can see that they are multiplying each other. So if they are multiplying each other, it means that we need to add what? Their powers, n minus 2. Same applies with 5 to the power of n plus n minus 2. And then the denominator, we're just going to keep it like that for now. Let's keep it like that. And then now, if I simplify this part at the top, right? If I simplify this, it's going to be 2n plus n, which is going to be 3n. So let me just work it out there. 3n. And then now here, we have minus 2 and minus 2, so it's going to be minus 4. There we go. Then now you can see we've done with the top part. And with this second one is going to be n plus n, which is going to be 2n, and then minus 2. There we go. So now here we've done with the top part. Now we need to consider working with the bottom part. Now this 2 is dividing with this 2, so which means if they divide each other according to the laws of exponents, they're going to minus. So we're going to say minus, and then we're going to take this one and write it as it is, 3n minus 3, right? And I do the same thing with 5, 2n minus 2. What are you going to do? Minus. What are you minusing? Minusing 2n, right? So this way it is easy to always take the one at the bottom and then bring it at the top, because this way you just don't get to leave the one at the top as a numerator, you know, because the one there at the bottom is going to be the invisible denominator anyways. This then gives us 2. Okay, here we have 3 n minus 4 minus 3n plus 3 times 5 2n minus 2 minus 2n, and then this cancels with that, and then also here I can say this cancels with this one, and then on 2 we're left with minus 4 plus 3 is going to be minus 1, and then here it is going to be times 5 minus 2, right? Now you see here we're left with 2 exponents, but they have a negative what? We left with 2 exponents and they have a negative power. So with the negative power, you know that if it's 2 to the power minus 1, 5 minus 2, we know that this 2 is going to have its 1, and that 5 is going to have its 1. So let's just write this one as the value that they both have, right, as an invisible denominator. So this means now the 2 is going to go to the bottom, right, leaving 1 at the top. Make sure you remember that. So this is going to be 1 over 2, right? What about this 5? This 5 is going to do the same thing. Because it's negative, it's going to go to the downside, leaving 1 at the top, right? So I can write this 1 there just to make things clear, and then take this 5 squared here, and then this part, this is where you're actually done, because this is going to be 1 over 2 times 25, which is just 1 over 50. So I hope this makes sense. Now let's go ahead and see how we're gonna do another one. Now with this one here, I wanted to show you how you can basically understand factorization on the exponential expressions. So the factorization is mainly basically on how you can see what type of a factorization to see, or what are you going to what type of factorization are you going to use necessarily. Yeah, I think that's one. How to use the factorization. So the number one rule on exponential expression, just like we did on the expression, is to always first do what? Prime factorize, because this basically, it helps you to understand what is happening on the expression that you're having there, right? Now here I can see 4 is not a prime number, so if I prime factorize that, it's going to give me 2 squared, so it's going to be 2 to the power of 2x then, right? Minus 3 times 2 to the power of x minus 4, all divided by 2 to the power of x plus 1. Now how do you see now that you're supposed to factorize here? You see by the distinction here on the numerator and the denominator. So here you can see that on the previous expression we only had one term on the numerator and also one term on the denominator, but now here on the numerator now we have 3 terms, and then on the denominator we have 2 terms, which means now here we need to change these and write them by means of what? Multiplication. That's why we know that we need to factorize. But now how do you know which type of a factorization that you need to use, right? How do you know? You focus on the exponents. So let's look at the exponents that we have here. The exponents that we have here is 2 to the power 2x and 2 to the power x. Now they basically look at their powers. Their powers, this one it is 2x and this one it is 1x, right? Now if this one, or if one of the terms, right, is 2 times another term, then this means we're going to do what? We're going to do a trinomial, right? Because here we have 3 terms, right? And then now we want 2 of those terms, they have a power of x, and then one of them is twice the power of the other. So this then means this part is 1x and this one is 2x, then this is going to be a trinomial, right? So because of the trinomial, we're then going to do what? Let me just say trinomial. So this means now we're going to do what? A factorization, right? And then now we're going to do that by applying a K method. Now by applying K method, what we're going to do is we're going to let K, right, to be the exponent with the smallest power, which is 2 to the power x, and then we're going to let K squared to be the one with a double power, or with the highest power. So this then means now this is going to be K squared minus 3K minus 4, all divided by K plus 1. Now you can see that at the top it's a trinomial that we're familiar with, so we can factorize that, right? So this is K, this is going to be 4, 1, and minus plus, all divided by K plus 1, cancel out, so K minus 4. Then now this is the solution that we have, but we're not done because we're working with x, not k. So this means once we have done simplifying this one, we're going to bring back the 2 to the power x back to where it belonged, and that is the final solution. Now do you see how easy that is when you start by prime factorization? So this then means now also there are also the exponential equations, right? In the exponential equations, it's going to be fairly the same way, right? But now I'm here in this one I brought this equation so that I can help you understand also another method that you can look into, right? Now here let's look at this one. In these equations you can see here we have 3 to the power of x is equals to 4 minus 3 to the power of 1 minus x. Whenever you're dealing with exponential equations, you must always make sure that first you prime factorize, and then secondly you make sure that the the exponents, they have a power of x, right? They don't need to have two terms in the power. For example, like this one, see here we have 1 minus x. They don't need to be like that. They need to be just 3 to the power of minus x. That's okay. 3 to the power x, 3 to the power 2x, and so on. You get my point. So this means now here, the first thing that we need to do here, first, always make sure that you prime factorize, right? And then secondly, the most important tool or thing to do is to isolate the exponent. So I'm not sure if isolate was the right word, or decompose. I think decompose, I'm not sure, but yeah, this means by isolating, this means now you need to make sure that you leave the exponents alone, right? Make sure that you have the exponents alone like that, because you can see here this part, it has been decomposed from that part to this part, but this is the only focus that we have here. This is the only thing that we're trying to focus on, right? Now, another thing that you want to make sure that you don't do is do not keep an exponent on the denominator, because 3 to the power of minus x, it is 3 over 3 to the power x, right? So make sure that you don't keep what? You don't keep an exponent as a denominator. Always make sure that it's on the numerator. So how do we do that with this one here? So the easy way to do this one is by multiplying everything. Just to multiply everything by that denominator exponent, which is 3 to the power x. So if we multiply everything by 3 to the power x, now are we allowed to do this first? Let me just start with this one. Are we allowed to do this? Yes. Why? Because we have an equal sign. So if you don't have an equal sign, you're not allowed to do that, right? And in most cases, they will never give you an expression to simplify that will have something of this nature, right? That will require you to do that. But if they do, you just need to know that you shouldn't multiply by 3x, because there's no equal sign there. So when you multiply by 3 to the power x, 3 to the power x times 3 to the power x is going to be 3 to the power 2x, right? Because it's going to be 3 to the power x times 3 to the power x. Same basis, we just add the powers, x plus x, which is just going to be 2x, equal 4 times 3 to the power x is going to be 4 times 3 to the power x, because they're not the same. Now 3 to the power x times minus 3 over 3x, what's going to happen is that the 3 to the x is going to cancel with the 3 to the x, right? So this means we're going to be left with minus 3. Then now here you can see that we have now two exponents, and then these are 3 terms. So because it's an equation, it is always advisable that we take everything on the left and write in this, make it a standard form, something like that, right? And then from there we can see now here these two exponents, these are 3 terms, which is try. Then now here we have 2x and x, and then you can see that this one, this power, which is 2x, is twice this one. So this means we're going to work with the factorization, which is the trinomial, right? So now here we need to do the k method. The k method. So how it works is going to be k 3 to the x, k squared 3 to the 2x, right? So this means now we're going to have k squared minus 4k plus 3 is equals to 0. Now we know what to do here. We factorize. We factorize. Let's see, k 1 3 minus minus. So k is 1 or k is 3. And then from here, once we're done, we're going to have 3 to the power x is equals to 1, and 3 to the power x is equals to 3. Now once we get in this point, we need to solve for x here. So solving for x, this is exponential equation, and then we know this is a basic exponential equation. The way it works is that we need to make sure that in these two equal sign, we need to have a term in this part on the left hand side that has the base of 3, and also on the right hand side we should have a term with the same base as this exponent that is on the left hand side. So this means now here we have 3, but here we have 1, but we can also write 1 because 1 is an axiom, right? We can write 1 as 3 to the power 0 using the axioms that I've showed you earlier. So this then means now here we have 3 to the power of x is equal to 3 to the power 0. Then if we have the same basis, then it means the same powers are going to be the same, right? Same applies here. We have 3 to the power x is equal to 3 to the power 1, means same base, also same power, right? So I hope this makes sense. And if you want to test it, you can just go in the calculator and then you're going to press it there. But in most cases, you don't need to test this one because it's an exponential equation. But one of the things that you're going to be testing though is when you're discussing on the rational exponent. Now, did you notice that on the exponential equations, the base is there, they were numbers, but the power were variables, which is x. Now let's look at the rational exponential equation, right? Or rational exponential expressions. The rational exponential expressions, you can see that here the value here, the power, it is a number, but x, right, the variable is the base. So now the first thing that we need to do is here we're going to apply the law of the exponential, right, of the rational exponent. We can see we have square root of x cubed, so this will mean this is going to be x to the power of 3 over 2 times x to the power of 1 over 6 over x to the power of 2 over 3. Now what I like about exponents is that you can apply the laws of exponents anyway, right? On rational exponents and also on the regular exponents. The roles, they are the same, they don't change because they work on exponents, right? So this means now here we can just add these two. So it's going to be x is going to be 3 over 2 plus 1 over 6. Then now here if I'm adding this x to the power of 2 over 3, so if I'm adding this 3 over 2 plus 1 over 6, so it's going to be 9 over 6 plus 1 over 6, so it's going to be x to the power of 10 over 6. But if I'm simplifying that, it's going to be 5 over 3, right, over x to the power of 2 over 3. Then now they're dividing each other, so it's going to be 5 over 3 minus 2 over 3, which is x power 3 over 3, and that is just x. Sorry, that is just x. Alright, so I hope that makes sense. So let's go ahead and look into the rational exponential expressions when you're doing factorization. So here, when we're dealing now with the factorization of the rational exponential expressions, what we need to do is first make sure that we apply the rational exponent rule, right? We're trying to make sure that we always keep it on the powers, or we keep the variables as like that, and then now we change everything and then we write it with the power of a fraction. So let's go ahead and do that first. So by doing that, we're gonna only change these two, right? You can see we're gonna change this one and that one. So by changing that, we're gonna have x to the power of 2 over 5 minus 5x1 over 5 plus 4 over x1 over 5 minus 4. Now what is the trick on rational exponential expressions? The trick into understanding this is basically looking at the powers, right? Now here in the rational exponential expressions, we're only focusing on where there is x, so we're going to focusing on these terms here. So now here the only rule that works is that you always need to make sure that on the rational exponents that you see the fraction, they all have the same denominator, right? That's the first thing. So always check the same denominator on the fraction, right? Check same denominator, right, on the fractions, right? So if we see here we have 5, 5, 5, so are the same, right? Then now once you get that, then it means you're basically on the right track. So what's the second thing that we need to talk about then? The second thing that we need to talk about is you only focus on the numerator, and once we're done with doing that, we're going to focus on the denominator later. So looking at the numerator, you can see that on the numerator here we have 3 terms, which means try. But then now looking, well, in the numerator, yes, we have 3 terms, which is try. And then looking at the 2 rational exponents, the first one, the first numerator of that fraction, you can see that it is twice the numerator of the second term, right? So this means if this is twice that, then it means this is going to be a factorization. And what type of factorization is that? Because if we have 3 terms, it's going to be a trinomial, right? So now when you're applying the k method, what you're going to do is when I let k be equals to x to the power of 1 over 5. So it's going to be the rational exponent with the smallest fraction, which is 1 over 5. And then when I let k squared to be what? x to the power of 2 over 5. Do you see how easy that is, right? Alright, so this then means now we're going to have k squared minus 5k plus 4 all divided by k minus 4. Now can we do this? Yes, we can. Let's factorize. So here we have k and k, 1 and 4 minus and minus, and then here we're just gonna have k minus 4, and then this cancels with that. This is k minus 1. Now remember, we're not done here because we need to bring it back to where it was, which is in terms of x. Now k was x to the power of 1 over 5, and then that's gonna be our solution. Hope this makes sense. Now let's go ahead and look into this one. So now the rational exponential equations, if you understood the rational exponential expression of the factorization, it means this one is going to be basically easy. So what's the first step? First step is really looking at the rational exponent, right? You got it right. So we're looking at the rational exponent. What are we trying to do here? The powers of the rational exponent, they must have the same denominators. Now let's look at the denominators here. You see here and here, these are not the same, right? Not the same. So what does that mean if they're not the same? If they're not the same, it means we first need to make them the same, right? So let's go ahead and do that. How are we going to do that? Here we can see we have 4, so we cannot change 4 and make it into 2, but we can change 2 and make it into 4. So how are we going to do that? If we can multiply by 2 over 2, right? If we can multiply by 2 at the top and multiply by 2 at the bottom. So if we do that, we're going to have 2x to the power of 2 over 4 minus x 1 over 4 minus 3 equals to 0. Now you see what's happening here? Same. So if we have same, we're just going to focus now on what? On the numerators. What is happening on the numerators? Now in most cases it's going to be always like this. The numerator, the first one is twice the second one, or you will always notice that there's one that is twice another one. So if it happens that they are the same, that means it's going to be a highest common factor, right? Because you're just going to take out the common factor there. But we're not there yet, we're still here. So this then means this one is twice that one, and we have 3 terms, so that's a trinomial. So we're going to let k to be x to the power of 1 over 4, you guessed it right, and then k squared to be x to the power of 2 over 4. So notice what I did here. I didn't say 1 over 2, I said 2 over 4, because we are done with that one, because we've changed the nature of that one into this one. So now I'm focusing on that one now. So make sure that you keep that in mind when you're working on this. Alright, so this then means now here we have 2k squared minus k minus 3 equals to 0, right? So now we're going to factorize here. So factorizing 2k, k equals to 0. Then this, we need to multiply this with that. So it's going to be 2 times 1, and then this with that to get the middle term, and then this needs to be negative, and then that needs to be positive, right? So let me just see if I get that right. Oh no, sorry, I got it wrong. It's the other way around. This is negative and that should be positive. There we go. So this then means now here 2k is equal to 3, or k is equal to minus 1, and then k is 3 over 2, k is equal to minus 1, right? Now we're done here. No, we need to take it back to what? To x. So remember, x 1 over 4, k was x to the power of 1 over 4, yes. This is equal to 3 over 2, right? So I want to focus with this one first. So on this one, what we're going to do is, we're going to first, once we have something like this, right, we're going to take this and make it x, right? Because here the power is 1 over 4. So we want to try and make sure that we're trying to solve for x here. So to do that, we're going to square, well, sorry, when I raise this to the power of 4, then raising it to the power of 4, we're also going to do that here. So the reason why we're raising it to the power of 4 is so that this 4 can cancel with that, right? We don't mind what's happening on the right hand side, as long as here on the left hand side we're left with x. Now x is going to be, let me see if I can get my calculator. So x is going to be 3 over 2, right, all to the power of 4, and then that is 81 over 16, right? Or, let's look at the second one, x to the power of 1 over 4 is equals to -1. Alright, so in this one we're gonna do the same thing. We're gonna raise it to the power of 4, right? And then this means x is going to be 1. And then after you're done doing this, because if we're working with rational exponents, right, what you're going to do is you're going to test the answers. So when you test the answers, you're trying to see which one is right between these two values. Are they both right, or is one of them wrong? So let's go ahead and do that. So when you test this one, what we're going to do is we're going to open up our calculator. Right, so opening up the calculator, we're going to take the first value. So now as you can see, we're getting 0 here, which is basically the same answer as there. So this means the first one is right. So let's go ahead and look at the second one. Oh, you see, we're getting -2. So the second one is what? Is wrong. So this means now the first one that we got there, it was right, but this one is wrong. And then so the final answer is going to be x is equals to 81/16. So that's all I got for you today, guys. If you like the video, make sure that you leave a comment and also share with your friends so that they can also get this valuable information. And I'm gonna see you on to the next session. Cheers.